Let there be light. But what is light?
Light is the natural agent that stimulates sight and makes things visible.
But what is light made out of? A wave!
Particles.
To the beginning! In 1678, I was the first person to have an opinion on if light was a wave or a particle, and I decided it was a wave. Why is light a wave? Because of the Huygens principle. It states that for every point on the wavefront is a source of wavelets, which spread forward at the same speed. It basically explains diffraction. But what is diffraction? Diffraction is the bending of a wave around the edges of an opening or an obstacle.
But Huygens was wrong.
What?
Cue Isaac Newton. I came up with the theory that light travels as a stream of particles that originate from a bright source. After I use prisms to turn white light into colored light, but then turn that colored light back into white light with another prism. I quickly attacked the wave theory by showing math that particles would also follow the laws of reflection and refraction. I also pointed out that if light was a wave, then it should bend around corners as sound would.
But light does bend around corners.
What?
Francisco Grimaldi performed an experiment where light passed through a narrow slit and faint fringes he'd seen near the edge, showing that light does bend around corners. Then I performed the double slit experiment, which passed light through two slits and a series of light would show. If light was a particle, there would only be two lines of light. This shows constructive and destructive interference observed in two types of waves. And Dominique Francis Argo measured the speed of light in air and water, and because it travels slower in water, light must be a wave.
But Heinrich Rudolf Hertz discovered the photoelectric effect, which shows that certain metals would gain electric potential when exposed to light. Wave theory could not explain this, and so my theory grew in support. And then I explained the photoelectric effect by using quantum physics.
Ooh.
I said that light appeared in bundles of energy. These bundles traveled in waves. Certain reactions revealed a particle nature.
Oh, silly boys. I showed that photons could strike electrons during scattering, causing a change in wavelength. I described light as a particle and a wave. It just depends on how it's tested.
But what does that mean?
It means you're both right. In my time, wave nature of light was already proved and accepted by the science community. I took Einstein's photoelectric effect and made my own experiment. I fired photons at electrons. On collision, the electrons and photons scattered and actually increased the wavelength of light. This is called wavelength shift. The light lost energy when the wave increased. This would not happen with only wave behavior. I had to assume at first that photons and electrons are both particles themselves. To see the wavelength shift, you have to look at the experiment with particle nature in mind. And in this experiment, particle nature, not wave nature, was dominant. This is why, depending on the experiment or expectations, light can seem like a wave or a particle. Wave theory alone cannot explain Compton scattering. When the wavelength increases, the photons scatter. That's something that only tiny particles can do, not waves. Because of this, light has to be a wave and a particle, because each kinds of behaviors cannot independently explain all the aspects of light